Welcome to this video user guide to the Soaring Bird Sensitivity tool. This short video explains how the mapping tool can be used to investigate the soaring bird sensitivity of prospective development sites in the Middle East and Northeast Africa. The Soaring Bird Sensitivity Map is intended as a source of preliminary site-scale information to be reviewed at the earliest stages of the development planning process. It is designed to inform and complement subsequent environmental impact assessments and should in no way be viewed as an alternative to these more detailed, on-the-ground evaluations. The tool has been primarily designed to assist the wind energy sector. However, the data and analysis presented is of high relevance to a broad range of users. Part 1. The Basics. You can move around the map using the mouse or the navigation tool. A range of different map views, including satellite imagery, are available. At present, the tool covers the Middle East and Northeast Africa. The exact geographical scope of the tool can be seen by clicking on the Scope of Tool box in the legend. The information and analysis presented in the tool is based on a number of different spatial datasets, and most of these can be added to the map as visible layers. Important bird and biodiversity areas, known as IBAs, constitute the largest and most comprehensive global network of priority sites for biodiversity conservation. They are identified using standardized criteria relating to species vulnerability and irreplaceability. On the map, IBAs are displayed as two separate layers. Firstly, those IBAs that are known to support soaring birds and for which there is associated population data. And secondly, those IBAs without associated data on soaring birds. Although these sites may support some species of soaring birds, no systematic data has been collected, and their ornithological importance is not related to the presence of these species. A large number of soaring bird observations have been collated and are also presented on the map. These records have been obtained from a range of literature sources and from the World Birds Database, a global portal for the submission of bird observations. The tool contains several hundred satellite tracks for individual soaring birds, which have been generously provided by academic contributors. There is also a layer showing the protected areas within the region. Topography is known to be an important factor influencing the collision risk of soaring birds with wind turbines and associated infrastructure. Consequently, the tool includes a layer showing all slopes with an angle greater than 14.5 degrees. Such ridgelines are frequently used by soaring bird species who exploit rising air masses to maintain their soaring flight. Though not visible, the tool also contains spatial data on the ranges of each of the 83 soaring bird species that occur within the region. Part 2. Performing a sensitivity search. In order to carry out a sensitivity assessment, a user must define a search area. This requires using the sensitivity search instrument. If you have coordinates for a proposed development, you can add these as either decimal degrees for longitude and latitude for a simple point, or use the advanced coordinate field to delineate a polygon or line. If you have a shapefile of the proposed development site, you can import this directly into the tool. In order to reproject the shapefile accurately, it must be in the correct projection coordinate system, namely Webb-Mercator Auxiliary Sphere. Alternatively, you can simply navigate to the proposed development and delineate a search area by hand. This can either be done by selecting a single point, for example representing a single wind turbine, drawing a line. This is of particular use when examining the potential impact of power lines, or drawing the polygon that best represents the area of the proposed development. All search areas are automatically buffered to 20 kilometers. Soaring birds can travel large distances with ease, and it is considered advisable to examine data from the immediate vicinity in combination with that from inside the search area. It is possible to increase the size of the buffer if desired. Part 3. Interpreting the search results. In this example, a site on the Gulf of Suez in Egypt has been delineated. The tool automatically buffers the search area to 20 kilometers and begins to compile and analyze all of the soaring bird data that intersects with the site. After a few moments, a search report appears along the bottom of the window. Information relating to the different datasets is presented in different tabs. There is also a summary box with the key information. Hovering over the key information gives more explanation. For instance, within this search area, 30 species of soaring bird have been recorded, and, based on their range maps, 2 more species are potentially present in the area. The Species tab provides more information on these 32 species. There is the English common name of each species, the peak count of each species, and information on whether the species has actually been observed or whether its presence is inferred from the species range maps. In this example, the 2 species that have not been observed but whose range map suggests that they could potentially occur at the site are bearded vulture and Saker falcon. The source column shows where the data originated. For instance, whether it is information associated with an IBA or if it is a record taken from a scientific publication. For each species, a link is provided to a detailed species fact sheet on the BirdLife website. Clicking on a species reveals more information. For instance, at this site we can see that the peak count of up to 250,000 white storks dates from 1998, and that this represents nearly half of the species' global population. The storks are on passage at the site, moving between their breeding grounds in Europe and non-breeding sites in sub-Saharan Africa. The conservation status of this species, as determined by the IUCN Red List of Threatened Species, is least concern. In addition, we can see that the white stork has a Species Vulnerability Index, or SVI, of 10. This is a measure of the inherent vulnerability of this species to collision with energy infrastructure based on its morphology and flight behaviour. In addition to white stork, many other soaring bird species occur at this site in significant numbers. For instance, around 13% of the world's 11th sparrowhawk, 5% of the world's black stork, and 4% of the world's common crane pass through the site whilst on migration. Also migrating through this site are globally threatened species, such as the endangered Egyptian vulture and the vulnerable eastern imperial eagle. There is also a breeding population of the near-threatened sooty falcon. The summary also indicates that there are two important bird and biodiversity areas that intersect with the search area, and that both of these are known to support soaring birds. For more information on these IBAs, click on the Soaring Bird IBA tab. Here we see that the search area overlaps with one IBA and that a second falls within the search area buffer 8.5 kilometers from the site perimeter. For both sites, links are provided to detailed IBA fact sheets on the BirdLife website. Clicking on the IBAs reveals more information, including all of the soaring bird population data associated with the site. For this search area, there are two additional sources of observation records, which provide further data on the soaring bird species present in the area. We can also see that this search overlaps with 3 protected areas, 2 proposed and 1 designated. The final tab lists all of the individual satellite tagged birds that have been recorded passing through this site. In this example, the satellite tracking routes of 94 birds intersect with the search area. The majority of these are records of white stork moving through the site in spring and autumn. As well as collating this detailed information, the tool uses the data to calculate a single sensitivity value for the search area. Taking into account the proportion of the global population of each species present, the conservation status of each species present, and the inherent vulnerability, or SVI, value of each species present, the tool produces a maximum sensitivity score. In this case, a sensitivity score of 7.35 places this search area in the outstanding sensitivity category. To output all of this information, click on the Create PDF Report button. Assign the report a title and subtitle, and decide what information to include in the report. For instance, if you do not wish to include information on the protected areas that overlap the search area, simply deselect this before creating the report. Part 4. The sensitivity categories. There are 6 sensitivity categories, from unknown sensitivity through potential and medium sensitivity to high, very high and outstanding sensitivity. If a site has no associated population records of soaring bird species, it is placed in the unknown sensitivity category. However, although there is insufficient soaring bird data on which to base a sensitivity score, this should not be interpreted as meaning that a site has no or low sensitivity. Available information for this region is incomplete, and detailed environmental impact assessments should always be undertaken to fully understand the sensitivity of a site. Likewise, sites that fall within the very high and outstanding categories should not automatically be assumed to be unsuitable for all forms of development, and it may be possible that, with the right mitigation measures in place, development at these sites can take place without any negative impact on soaring birds. Again, thorough on-the-ground environmental impact assessments are essential. It is also important to note that the mapping tool only presents information on the 83 species of migratory soaring bird that occur in the Middle East and Northeast Africa. Although this is an especially vulnerable group within this region, it is vital that developers consider all of the biodiversity impacts associated with the project. An authoritative source of wider biodiversity information is the Integrated Biodiversity Assessment Tool known as IBAT. Thank you for watching this video. If you have any questions regarding the Soaring Bird Sensitivity Map or the Migratory Soaring Bird Project, please contact BirdLife at msbtool@birdlife.org.